Welcome to the machine learning series. In today's session, we would understand a basic intuition behind the linear regression algorithm. So in today's topic, we would be seeing what is linear regression. Then we would also be seeing what are the types of linearity. And then I will show you the machine learning pipeline and what is the idea behind the linear regression. And then we will talk about few functions in today's session. So linear regression is the algorithm that is to find the linear relationship between the independent and the dependent variables. Now you might be thinking, what are independent and the dependent variables? So if I take an example, let's say you want to predict the price of the houses. You want to predict the prices of the houses. Okay. And if you think logically, what are the parameters that could affect the price of the houses? Okay, there could be a locality. One of the parameter could be the locality, the build quality of the house, the build quality of the house. It could also have the age of the house, right? And there could be a facilities in the house. Okay, now if I talk about the prices of the houses, this is nothing but it is known as the dependent variable. Dependent variable. Okay, in machine learning, we could also call it as response variable. We could also call it as target variable because we are trying to predict the prices of the house. And the features or the columns or the attributes which would define the price of the houses, those are known as the independent variables. Okay, independent variables. This could also be called as the features, okay, or the attributes or the factors. Okay, one and the same thing. Okay. Now we understood that, okay, what is independent variable and what is dependent variable. And in linear regression algorithm, we want to find a relationship, a linear relationship between the independent and the dependent variable. Okay. Now, what we would be doing in this linear regression, let's say if I take an example, let's say if I take a dictionary and let's say in that dictionary, I have the age of the house. Okay, let's take 10, 20, 30, 40, 50. And with the age of the house, and let's say 60. And I have another variable as the prices, the house prices. Okay, let's say 5, let's say 6. Then I want to say, oh, let's say, let's say. Okay, so these are the ages of the house and these are the prices of the house. Now, let me convert this to a data frame, and let's say dict1, and let us see the data frame. Okay, let me just import the library, import pandas as PD. It will take time. Meanwhile, okay, there might now you would see we have the age, and with the age, we want to see how the prices are moving. Okay, we want to see how the prices are moving. Now, if I'm taking one dependent variable, one independent variable and one dependent variable. So the independent variable is age and the dependent variable is prices. This is known as the simple linear regression. What is simple linear regression? When I would take one independent variable and one dependent variable and try to apply the linear regression algorithm. That would be called as the simple linear regression algorithm. Now I want to show you the matplotlib dot pyplot as PLT. Let us try to plot the scatter plot for this. Okay, PLT dot scatter TF of age, TF of price, and let's see its prices. My bad. So you would see as the age of the house is increasing, the price is decreasing. As the age of the house is increasing, the price is decreasing. Okay. If I want to draw a line, let us also draw PLT dot plot DF of age, DF of price, and let us draw that line in red color. Let's try to see. So you would see as the age of the house is increasing, the price is decreasing. Okay. Now in linear regression, we want to fit a line. Okay, so it's the concept behind the linear regression is based on the line of equation of the line. Okay, equation of the line. So if you go back to your class 11, 12 maths, if you are coming from the mathematical background, then you would know that the equation of the line is given by y equals to mx plus c. Okay. Now, if you're not coming from that background, don't worry. In this session, you will come to know what is y, what is m, what is x, and what is c. So with this equation of the line, we can predict, okay, what are the points? Okay, what is the equation of this line? I can predict, okay. So the generalized formula is this, and here m is nothing but the slope of the line. At this point in time, you should just understand the terminologies. We are not going mathematical intuition behind the linear regression. And C is nothing but the intercept. Okay. Now, if I want to convert or if I want to use this equation of the line in the linear regression, so I would be writing as y as the target variable. Target variable is equals to m into my independent variable plus c. Okay, this could also be known as, okay, there are few notations. I just want to tell you about the few notations. M is equals to slope. Okay, in normal equation of the line, m is known as slope, but in machine learning you might see a notation as coefficients. We will call it as coefficients, or we could call it as weights. Okay, we could denote it by thetas. Okay, I could also denote it by betas. Okay, there are different notation, but the underlying concept is this. Okay, we got slope in general maths. Okay, in maths, whereas in machine learning, we might call it as coefficients, weights, thetas, betas. C is intercept in normal maths. Okay, or you could call it as constant. Okay, in machine learning, you would call it as bias or error or intercept, one and the same thing. Okay, so let us assume that if I want to predict the equation of this line, okay, I want to predict the equation of this line. I know this is my age and this is my house prices. Okay, if I write here PLT dot X label, let's write it as age, and PLT dot Y label, and let's write here prices. So you would see as the age of the house is increasing, the price of the houses are decreasing. Now let's say if I want to represent this, we are just talking about the representation. If I want to represent this on the equation of the line, so I would write my predicted. So let's say I want to predict the price. Okay, predicted price is equals to the independent variable, let's say age, and what is the weight associated with this W1. Okay, weight plus C or intercept. Okay, So you would see I have one dependent variable, one independent variable. Okay. And if I'm able to find this weight, if I'm able to find this or weight or slope or coefficient and intercept intercept, then I am able to predict the price of the houses. I am able to predict the price of the houses, right? So that's what our main motto behind the linear regression is, that we need to find these unknowns. We don't know M, we don't know C, we know X. Here we know the values of age. So see, here age is present. And we want to find the predicted price. Okay. We are interested in finding the predicted price. Okay. We want to see that how good the fit is, how good the line is fitting to these points, and how our algorithm is performing. So our main motto is to find these unknowns. Okay. So now we understood that, okay, the equation of the line is y equals to mx plus 3c. I can represent it in the form of theta. So I can replace m with theta. Y equals to theta 1x plus theta 0, where m or theta 1 is the slope of line. C or theta 0 is the intercept of the line. We know x is the independent variable and y is the dependent variable, or the one which we need to predict, right? Now, see, there could be a possibility in this case, if I draw the line, okay, here you would see as the age of the house is increasing, the price of the house is decreasing. So it is a negative linear relationship. It is a negative linear relationship, because if I'm trying to increase 1 unit of X, there is a decrease in 1 unit of Y. There is a decrease in 1 unit of Y. Okay. Now, let's say if I include one more variable here, let us include one more variable here. uh, as the build quality. Okay, let's say build quality, I'm giving it as 1. Okay, uh, 1, 1, let's say 1.5. 1 is very good build quality, let's say out of 5. So I'm giving the ratings out of 5. Okay, so let's give this as 5 rating. Let's give this as 4.5 rating. Let's give this as 4 rating. Let's give this as 3.5, and let's give this as 3. Okay, so this is the build quality. And okay, 1, 4.5, 4.5. Okay, 4, 4, 3.5. Okay, so these are the ratings. Okay, these are the ratings. Okay, now let's say if I want to plot this, now I am plotting this build quality. Let us plot this build quality. Plt dot plot. I want to plot df of build quality, and I want to plot df of prices. Okay, now you would see here that as the build quality is increasing, the price of the house is increasing. The price of the house is increasing. It's not a linear, it's okay, but there would be a straight or linear line, right? There would be a linear line. So this kind of relationship is known as the positive linear relationship. Okay, so we have two types of linearity. One is positive linearity and another one is the negative linearity. Okay, the positive linearity is defined as a positive increase effect with respect to its cost value. Positive increase. So if I move 1 unit of Y, so there would be increase in 1 unit. If I move 1 unit of X, there would be increase in 1 unit of Y. Okay. If I talk about negative linear, if I increase or move 1 unit of X, then there would be a decrease in 1 unit of Y. Okay. So there are two types of linearity. One is positive linearity and another is negative linearity. And we also saw that in the linear regression model, okay, the slope and the intercept parameters in the formula are the adjustable parameters. I would show you in the Excel in the next session when we will try to solve the linear regression using Excel. This slope or weight or coefficient and the intercept are the adjustable parameters. We want to find the values. We want to find the best values for the slope and the intercepts. Okay. Now, if I talk about in machine learning, the main idea is to reduce the error. If you talk about any machine learning algorithm, okay, how could I say that whether my algorithm is performing good or not? So the main idea or the crux behind all the machine learning algorithm is to get or a good prediction with a high accuracy and reduce error. Okay, if you're trying to minimize the error, the lesser is the error, the more good is the model. Okay, so here is an example that we would take in our next session. So here we would have the temperature, water sold, and this x is nothing but independent variable. This y is nothing but a dependent variable. And if you want to predict that, okay, on the basis of temperature, how many liters of water you are selling, if you find the slope and the intercept or the coefficient and the intercept, then your linear regression problem is being solved. Okay. Before we try to solve that, let us go and understand a simple machine learning pipeline, how it works. So I would get the input data. Okay, I would get the input data. So let us assume that this tabular format is our input data. And then we might do some kind of feature extraction if required. Then we will push this prepared data to the model, okay, machine learning model, and then we will calculate the loss. Okay, if you feel that okay, loss is we have minimized the loss and our algorithm is doing good, then our machine learning algorithm is ready for production. If you feel that okay, there is more scope of reducing the error, then you can perform the optimization and you can go back again to the machine learning model. If you feel that okay, I can extract some more feature and optimize the error, then you can again go back to this feature extraction and we can again do the same process. Okay. Now, if I show you, this is the simple machine learning pipeline flow, how it works. We are not zooming in into each of these boxes. Slowly and steadily, we'll try to zoom in and try to see what are the insights in these boxes. Okay. Now, what we will be doing is we would try to learn the concept of the slope and the intercept. Okay. Here M is the slope and C is the intercept. If you try to see this figure here, okay, the intercept is nothing but the cut on the y-axis. Where this line is cutting on the y-axis, that would be known as the intercept. Okay. And slope is nothing but the angle between the x and the y-axis. So if you see here, here we have the increasing slope. Okay, the slope is increasing. If you see this picture, or let me zoom in, here the slope is 0. Okay, but the intercept is something where we are cutting this line on the y-axis. Okay, here if you see in this, the slope is increasing, but the intercept is 0 because all these lines are cutting on the y equals to 0. Okay, so the objective of linear regression algorithm is to choose the optimized value. Please note or focus on this keyword optimized value. So we are trying to choose the optimized value of slope and intercept so that the line fits the data with the less errors. Okay. Now, before we move on to machine learning, let us understand few of the loss functions that we would be trying to calculate. Okay. So the loss function is nothing but the predicted output and the actual output. We are just doing a difference between them. Okay. So the loss in linear regression is calculated as the difference between the predicted values and the actual values. In linear regression model or linear model, there are two types of losses. One is L1 loss and another is L2 loss. What is L1 loss? If you see, let us assume that this is a scatter plot and this green color line is the predicted line that we predicted or that our machine learning model predicted. Now, if you see this dot 14, okay, this 14 is the actual value. And let's say when I draw a perpendicular line to this green color line, okay, you would see a red dot is appearing. So I got this point as 11. So the actual value was 14, but our model predicted 11. Okay, so the difference between the actual and the predicted is known as the mean absolute error. So here we are getting the -3 as mean absolute error. So we are predicting 3 less from the actual values. Okay, if you take the another example, so let us see that the actual value is 5 here and the predicted is 10. If I take the difference between the actual and predicted, the mean absolute error would be 5. So you would see here we are doing a positive 5. So it means we are predicting 5 more from the actual values. At this point in time, you just need to understand this graph. Okay, and when I will upload the next YouTube channel or YouTube video over the channel, so I will show you everything in the Excel and you would get more clarity on these concepts. Now another type of loss, if I move down, there's another type of loss which is known as the L2 loss. We are not worrying about this error at this point in time, how it is calculated. So what it is doing is, so let's say if I got mean absolute error here is 5, here is -3. So what I will do is I will club or sum all these values and divide by number of observations. Divide by number of observations. But at this point in time, we are not worrying about this formula. In next session, I will show you how to calculate all these things. If I talk about L2 loss, so L2 loss is nothing, but it is the squared average difference between the predicted and the actual value. And it is also known as mean squared error. What does it mean? So if you see when we are calculating the mean absolute error, we are also getting the negative values. To get rid of those negative values, so what we did is we calculated the square of these values. That's it. So that's why it is known as the mean squared error. So if you see the formula of mean absolute error and mean squared error, here also we are taking the difference of the actual and the predicted. This yi had is the predicted and this yi is the actual. And here we are just doing a square. And we are just summing all the observations in mean absolute error and dividing it by total number of observations. Here also we are summing all the observations and dividing it by total number of observations. The only difference between L1 and L2 loss is that L1 loss is the absolute difference between the actual and the predicted values, whereas mean squared error or L2 loss is the square difference. So that's where we just take a difference and then do a square to get rid of the negative values. Now you would also see the one more type of error that is based on the L2 loss only, that is known as root mean squared error. It tells us the error rate by the square root of the L2 loss. So what we are trying to do is once we calculate the L2 loss, we would take the square root of that and that would give me the root mean squared error. So basically, or in a crux in linear regression, there are only two types of losses, L1 loss and the L2 loss. L1 loss is known as mean absolute error and L2 loss is known as mean squared error. If I take the square root of L2 loss, that would be known as root mean squared error. Okay, now we understood the losses, but how about the best fit line? Or how would I know that how my model is performing? How would I know, okay, in this graph, let's say, is this my best fit line? Or is my model able to capture all the variance in the data set? So to know the goodness of fit of the model, that okay, is my model doing good or is this the best fit line or not? To know the goodness of fit, that's where we have one more metric that is known as R squared error. That is known as R squared error. So what does R squared error tells us? It tells us that how good the fit of the model is predicted with its actual data. Okay, and this value ranges between 0 to 1. The value ranges between 0 to 1. And how do we calculate the R square? We just subtract R square by 1. Okay. And in the numerator, you would see we have the yi minus y hat whole square, actual minus predicted whole square. you would see it is the same formula here coming in the numerator, and we would subtract all the data points with its mean and take the square. So in next session, over the Excel, I will show you how these things are calculated. Okay. Also, you need to know that in case of outlier, we can use the L1 losses because the L2 losses would be squared up and there would be more loss over this. Okay. So we can remove the outlier first and then we can use L2 loss. Or if we have the outliers in the data set, then let's go for the L1 loss. So I think guys, that's it. I just want to give you an overview in this session. I hope you learned something new. Stay tuned to my channel, like and subscribe to get more updates. Thank you.